Hey guys, this is Juan Saco. Welcome to this online training. So we're gonna do today a walkthrough the tool that has been released from the NSA. But first, I don't know if anyone that is already on the meeting, could you verify, confirm that you can hear me correctly, so I can proceed? So can you guys hear me? Please confirm me. Maybe not. Let's check. So anyone could please confirm that you can hear me through the microphone, maybe on the chat, or unmute yourself. Yes. Okay. Perfect. Then I will go ahead. Okay, guys. So basically, you might hear that the NSA yesterday they have released this tool called Ghidra. I don't know what is the correct pronunciation for it, but it's basically it's a reverse engineering tool that you can use to statically disassembly and understand better binary. Basically, that's the main purpose of it. You can find it. Let me remove the chime. Just a second. I think it's here. Just a second, guys. Yeah, there you go. Yeah, because a lot of people is getting into. So, okay, let's continue. So basically, you can get the tool from this website, ghidra/sre.org. It will take you to the official website of Ghidra. And here, if you click download Ghidra, then you will get the binaries. They also have a GitHub page, but basically on the GitHub page there is only a template for it. They haven't released the source code yet, but it's you don't have to. At least I think you don't have to be aware of any issues with the tool, with security related, because it's all in Java. They also use Python as scripts, some of them, mostly Java. So you can get Java and the compiled code. So if you want to take a look. There is also yesterday a guy in Twitter claimed that there was a remote code execution. I think the word remote code execution is a pretty strong one for this case, because actually the finding was that the tool itself, when you launch it, it will if you do it in debug mode, then it will choose open the typically the debug mode for Java, so you can actually write Java code into it. But I don't think that's a remote code execution. That's how a standard application in Java behaves if you use debug. Okay, so I've been playing around with these tools for a few hours now. So it has, as I say, it has been released yesterday, but I went through the whole manual that they have. So basically, I can show you some examples. So basically, what I'm gonna show you is how to go to the vulnerable server that I supposed to, this one, the vulnerable server from Gray Corner. It's on GitHub, and also we go to a simple crack me, so you can actually see how the tool works. And also we're gonna go into the goods and bads of these tools, and also what do we can expect in the future about this tool. So I'm pretty excited. So let me should say from the beginning that I really like the tool. I used Ghidra Pro for a long time now. I start my way with only DBG, and then I move into Immunity with DBG. Then of course I ended up using Ghidra Pro. Now that I see this tool, I think it's a really nice competition for Ghidra Pro because of the features that they have, and also for for the path that it could follow if this evolves in a good way as an open source project and people start getting involved into it. And also, I'm really aware that all the press that this tool received, and I think it's gonna keep receiving more press because, of course, NSA and because of the tool is pretty well made. So I think there is a good future for this tool. So as I said, you can just go ahead and download Ghidra from their official website, unzip the folder, and it should do it should be the same for. And I think I have it here. Yes, Ghidra. Yeah, basically you have the tool there. It's the version 9. As far as I remember, on WikiLeaks they have leaked from WikiLeaks the version 5 or 6, something like it. On that moment, I tried the tool, but it's totally different now, and it works way better. So you get the tool here. The first thing you want to disable is the under launch. So if you go to launch Sage, and then you can look up for, I think I already have it commented here. Is it this file? Maybe on the other one? No, it's in this one. So basically go to this line, the one that I'm highlighting now. On this line, then you can disable one of the arguments for the virtual machine of Java. So it will disable this argument. Basically, it's not gonna open any port and any address in your machine. So the debug interface will be closed if you decide to use under debug mode. So if you run the tool, I can close it here. I was already using it. Don't save it. So if you run it in Ghidra debug, then in any case, it will not open the port. So I'm running the tool now. Then now if I check, the port is not open there. So it's not that I don't need it. I mean, I'm not debugging the tool, so it's not that I have to. You can also change it instead to open the interface for the whole world to 000, and then the port you can choose close it and then don't use it. That's what I did by just commenting that line. So basically that's about the remote code execution. That I don't think there is none as far as I know. So basically, when you have this tool, of course, let's go a little bit back. So you will get this, and then if you are in Windows or Linux or Mac, of course, if you are in Windows, choose double click on the bat file. So basically, you will have all your char, your libraries, and everything inside this folder. So you can find those inside Ghidra, I guess here. Yeah, then you have the configuration extension, feature frameworks. Also, you have a folder for scripts, the scripts that they got, and I think inside GPL, you will have all the GPL libraries that they are using. Inside documents, you will have all the documents from Ghidra. Inside also there is an installation guide if you get stuck in the middle, but basically you will need to get Java. Yeah, just get Java from Oracle, but as I read, they also support OpenGDK. So if you run it inside Kali, Ubuntu, Debian, Parrot, any Linux distribution that comes already pre-installed with Java, then it should work just fine. Or otherwise, you can go to the Oracle website, and instead of using OpenGDK, you can also use Java from Oracle. That's that I think what I have now. You can check your Java version and doing Java minus version, and then you will check your environment. Your Java environment should be in user leave, JVM, and then you will have all your Java environments. Those are the ones that I have installed on my machine. And then if you do M, then you can check if you have your Java home properly set. Otherwise, the script that we will call Ghidra RAM, this one, it will try to look for that one as well for the Java home, because it goes as you see It goes to script, blah, 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 and then it goes to launch.sh, and then it's launch.sh that is inside the support folder. Yeah, for Linux, of course, it will look for Java Home and then choose run. It will choose run it like a normal Java application, passing the class that is gonna launch first. That's all. Something you have to check if Java is behaving really slowly. Then what you can do is to go to Java run and then edit that file like that, and then you can change the max mem to use like 2 gigabytes to be more than enough. Most of the Java applications, they don't use all the memory, but they can allocate an X amount of memory. So by themselves, all the Java applications, they don't use that much memory. But it's way better if you have a lot of memory allocated for that particular process that you are running. It doesn't mean that it's going to use it, but at least they are allocated and they can use it. And remember that Java by itself also needs to run the garbage collector and be behind the scenes and a lot of stuff. So basically, if you can afford giving at least 2 gigabytes of memory for the process, then you should go ahead and use it. I think the 768 megabyte is the sort of the minimum requirements for the memory that the RAM that is gonna be supported by this tool. So as I said, run the .bat file if you are on a Windows machine, or choose run the launch and then go ahead launch sh if you are on a Linux or Mac OS X. So I'm on a Linux machine. I will choose, so I show you, you can change that and then choose run in the debugger. It says it's already running, so Adri is already in use. Yeah. So I have it here. So basically, this is the tool itself. The tool itself is not only a reverse engineering. This is, if you are new to this tool, it will amaze you, because it's not just a reverse engineering tool. The reverse engineering tool is this one. It's the code browser. Yeah. But of course, you also have a version tracking, but all these tool chests that it shows here is for all the tools that you can add into this framework. And the main purpose of this tool is to be a framework. So in the future, I'm seeing a lot of tools in the chest for exploit development, debugging, malware analysis. I think a lot of stuff is gonna come here if this open source project evolves. So, and also I also have a virtual machine here, with IDA Pro 7.2. So this is the latest version of IDA. So we can compare it a bit, or if you have any question or something you wanna check me or compare with the Ghidra or Ghidra, or whatever is the pronunciation of it. We can also do that. So basically, when you have the tool running here, then you can, if you want to start with it, this is the main thing I did. So you can go to help contents, and the help for this tool is amazing. It's really, really good. I mean, it gets into the tool and show you exactly what you need. I think the people that wrote the documentation for this tool, they really did a really nice job. And I hope they keep doing with that. And also inside the tool, not here, then you can also have some documentation about the API that you can use to interact with the tool itself. For instance, right off the bat, if you compare that with IDA Pro, I don't really like the documentation of IDA Pro. If you want to learn about IDA Pro, you have to go ahead and buy the book. That is not, you can find it in Amazon. And there is also a book about IDA Python that will also take you in the development of IDA plugins and how to interact with the IDA API. You can also interact with this tool and IDA, because you can export what you were working from IDA and import it directly into Ghidra as well. So you can import it as an extension, and it supports the IDA Pro 6.8 and 7.2. So both branch are supported of IDA. I think it's 6.8 or 7.2. You can confirm that. So basically, as I say, it has extensions, plugins, and scripts that you can run. So basically, the main tool that you have on your chest will be the code browser, and it's the one the more important one now, as it is. So basically, when you start this tool, you have to create a new project, and on this project you will add your binaries. These are the binaries that have been working so far. So when you want to add a binary, you can choose drag and drop it here, yeah, or choose create a new folder, or add the binary directly from here, or yeah, as I said, drag and drop it here. So let me make this full screen. So we can go ahead and start with the easy out. There is a Linux 64-bit binary. So we can double click on it, or open the tool and open it from the tool itself. So by itself, it's gonna open the binary here, or you can choose go file open and then choose the binary that you want, and it's gonna show you inside the current projects, because you can have more than one, a list of the binaries that you have here, right? So as I said, this is the framework itself, and inside the framework we are using one of the tools that is the code browser. Yeah, going back to the help, here you can also access the help for Hydra, yeah, but also you can access the API help. And if we go there, yeah, you can see here all the API calls that you can use to interact with it, with the scripts that we will go in a minute. This is all the scripts, and the tool is extremely modular. So basically, almost everything is a module of the tool that you can also modify or create new modules or create new scripts for them. And the scripts can be, you can write the scripts in Python, or you can write the scripts in Java. I'm not sure yet if you can, because this tool was just released yesterday. So, but I'm not sure if you can interact with the API using Python. I think you can, but I'm not for sure that you can interact with the API with Java, for instance. If you want to look up for something in memory, check for protections, check for, I don't know. I have a script that I wrote for IDA Pro for doing cracking, that it will check in IDA, using IDA Python, that is Python. It will check if you are using is debugger present, if you are using clubs. It will check for a few memory addresses that you might be using, and then give you an output based on that to see if the binary is using that kind of stuff as protections, just to check what the protections that could the binary be using or referencing to. And I think you can do exactly those type of things in the Ghidra in Python as well. But I know for sure that you can do that in Java. So when you open the binary, you will see first in the left side of the screen the program trees, the symbols, and the data type manager. Then you will have here the console, yeah. And also I added the Python interpreter into here. If you want to, for instance, you will not see it. You will see only this when you open the tool, but you can go here, window, and then Python, and then it will open Python, but not like this. It will open it in a detached window. But you can, it will be like this. So if you grab it from here, not from here or here, but you have to grab it from this bar, and then you can put it wherever you want. I like it to have it here, just like I do in IDA. think should be something like this. Let's just a second, like that. Okay, and yeah, and then you have a full Python interpreting 2.7. Yeah, and then here on the main screen you have your disassembly, and then I also added the function graph and the strings. So on the strings, if you go here, then you can choose. Let's look for this is the easy out crack me. So this is a pretty straightforward. It's just it's the most simple crack me in the world. I think the password is right there, but it's just to give you a walk through the tool itself. So you click here in one of the strings, and then you can go there, and it will take you, as soon as you click on those, it will take you there, right? You see? So I go back there. Let's go to the win false tries again. Okay, this is the it's not the win, and this is the win, and this is the fail message. Okay, here on the right side you see the references for this string. It could be more than one. For instance, this one has two, this one has only one. So normally in IDA you press X to go into the references. Also, if you do the mouse hover, choose like IDA, it will give you an overview of it with where is the reference on. Yeah. So if you double click on it, on the references, then you can see also every screen. You can put it wherever you want. For instance, I could drag and drop and put it here, this one. So, but in any case, it will, by default, it will pop up, and then you can go here or to the other reference, and as soon as I click, it will take me there. Okay, let's close this one. Let's go back to the other one. How do you go back? So you have the back, go to previous location or go to the right location. So it will undo whatever you were doing, right? So if I go here into this reference, but I was before clicking here, then it will choose go as well, you see? So what I did is press Alt and then cursor left, because it's the shortcut, is Alt left or Alt right. That's really easy to do. And there is also a history with one. So if you click here, and then let's go inside the function, and then when we go inside the function, it will take you to, in this case, on the text data. Let's go. And I already added some colors here, but anyway, as soon as you are there in here, then what it's gonna do is to show you the disassembly of the decompile of the functions that you are on. In this case, we are in main. So here also in the main tree, what you can do is to check for the imports. Yeah, in this case, because it's a Linux, it will use libc, GCC, and standard C, the exports. And also you can check for the functions. And here, this is a really small amount of functions, but you can also type here and then look for, on this case, it's main. That's the one that we are working on. Yeah. And as I say, here you have all your sections for this particular binary. Well, when you are here, let's go back. So going back is Alt cursor, and then we go back there. And then from here, we can also look up the code from the function graph. And as soon as you click something, it will take you there, but not only there, but also to the line that you are clicking on. So for instance, if I mess up all this, what I can do is to, I think it's this one, and then boom, it will make it up again for me. And if you go to the champs or any part that is gonna follow a flow, it will also show you here like this, because we have a champ set. And if you don't know what this means, then you can choose click the opcode of it, and then you can choose go into instruction function, and then it also will give you a quick instruction summary about it. It's a conditional jump in this case, right? And you can also change it by doing this, and then you can patch instruction. The pop-up message that showed me before. Sorry about that, guys. Maybe I can do it again. Patch instruction. Let me, from here. I don't think it's gonna show it again. Patch instruction. Now it's already letting me patch it. In any case, what I wanted to tell you guys is that this tool supports a really several types of processors, and they have a sort of a list of processors by support. And the x86 support, Intel in this case, is a gold. They have the gold standard. So basically, almost all process that will run on this tool and will be patched or decompiled or read it. They will be almost perfect. Yeah, it's not perfect, but almost perfect. Just I think IDA is sort of the same. So as I say, if you want to change this, you can choose do patch instruction, and then you can choose change it. And it has also auto completion. So if I want to change it for a jump, then you can choose click here and then check for different type of jump, or we can choose leave it as it is. As soon as you click here, this is something really cool that this tool has, is that as I show you here on the main graph, it will also take you into the compilation part, into the line that is positioned into. So basically, if you are not really good at assembly, then for instance, if you want to find what is this if, then you can just click on the if, and then it will take you in the disassembly part. I mean, from the pseudo C code, it will take you in the assembly part, which part belongs to that. So in this case, is B bar equals false. So what it's doing is in assembly is checking this, right? Test AL. That is the low for AX, and then doing this conditional jump, yeah, in the result, yeah. And it will be it will do the same for the assembly to the decompiled part as well, yeah. So yeah, and you also, it will sort of complete it for you, the highlight. So that's really good. I think for learning assembly, this tool is amazing. Yeah, like that. So in this case, for instance, here's where it's declaring the variables, and you can actually see it here. And here you have the variables. And also, for something that is really nice about this tool is that it will also give you the size. It will check the size of the strings of the variables. Sorry, not in this case it's a string, but for the variables, and also it will give you the size of it. In this case is 40 for this variable local 48. And 48 is not a random number; is the offset of on the stack. So as you can see, is this one is on 20 and this one is 48. So because there is something in the middle, that is this. I know that, but if we go somehow, I think we should go into the stack anyway. But that's the offset. Let's not spend time on that. So yeah, Going back to the function graph, something I like. So for instance, I already painted this. For instance, I know this is the champ, and then on this particular case, it will check for the variable. On this crack me, it's just asking for it's just asking for a string, and then if the string is correct, then it will choose do true or false. Yeah, and this is a string, and then you can as soon as you identify that, yeah, on this case is this false one, so you can change the color, and then do choose color, and then you can change the color. And this is something I really like, is that it's already remembered the color and leave it there for choose color, and then let's paint it again in another color. So well, this one should be green, and then like that, like true or false. I mean, if this one, see if it goes here, then it's okay. If it doesn't goes here, then it's gonna show your password is false. Yeah, it's false. It's try again. It's the wrong one. So if you want to look for a variable and where it's being used, you can click with the right click of your mouse on this one. For instance, where it's using V-bar, then I can choose click with the middle click of your mouse, sorry, and then it will highlight it for you as well, as you can see here. If you go, as you may notice already, V-bar is this one, and is allocating this chart with here with this value, yeah, and this is the value that is the password itself. It's a chart that is 0x86. So if you type this, then it will go here, and then it will say your password is true. Otherwise, it will be false. This code looks like this because, as you can tell, it's a C++ code. But maybe we can look for a different one. Let's save it. Then if you want to save it, you can choose click save, and then it will remember all the changes. Let's do the vulnerable server, but let's do it. Let's remove this one, and let's try to do it from the beginning. I think I should have it here, or maybe not, but I can get it again, right? From the website. If it lets me to click here, there you go. This is a vulnerable server. You know, if you are familiar with it, this is just a server that you can use to learn, exploit development, and do some funny things. But basically, what I want to show, why I want to show you this, is because we have the source code and we can compare it with IDA and also with the tool itself. Right, and it's not C++, but it's C, so it should be pretty straightforward. So what we can do is to take the binary. There is a Windows binary. We will take it into IDA. We're gonna put it here, and then I may have it already. So we can close this one. Don't save it, and then we put it into IDA. Just a second. So, okay. And then we have it in IDA. So we can go to the main functions, but let's go to the string. I can also show you how this vulnerable server works, so you can understand. Oh, it needs the DLL as well, so I have to copy it there. It's already copied. No, I did not. Yeah, sometimes Mine being where does that? Does the VM tools choose type choose fail. So let's don't save it like that, and then there you go. Now it works. So double click on it. It will open a port. Okay, 999. Then we can go to the Linux box, and then we can let me check for I don't know what's the IP of this machine. So it's 172.16.4.7.129. 247.16 or the other way around. The other way around. 129 port 9999. No, that's not the board. 16247. Percent 129. What's the port? Should be 9999. Let's start. Oh my god. Yeah, it's 99999. What did I type? That's not running. There you go. Wow, that was crazy. I should close it and open it again. So basically, this is a connection to blah blah blah. I choose open it with Netcat, and then sends me. It greets me with a welcome with a welcome message. It's welcome to Variable Server. Press enter to help. Most of these commands they are vulnerable to something. Yeah. So you can type a command kstat or kstat like that. Unknown command. Okay, kstat a. Okay, stand. Whoa. A L time A or something like it, and you can interact with it, right? So basically, with this, you can write your own exploit, learn to write a remote exploit, get to write a egg hunter, SCE, CA exploit, standard execution handler. Exception handler, sorry, execution. But yeah, you get in the end execution, and how to use your champs backward and forward by writing your exploit, and then some cases they are really tricky because you have to use egg hunter, and then you can because the stack is really small, and yeah. So for those kind of type of exploits, and it's kind of a CTF. If you like it, if you haven't done this before, then you will find it pretty fun to do. But on this case, this is about Ghidra. So what we're gonna do is to open it in IDA, and we're gonna do the same. So let's check for one of the strings. So I choose open it in IDA Pro, and if you are familiar with IDA Pro, it's similar to Ghidra, but it has a debugger. So double click on this one, and then here you will have your reference. You can also click there or click on the name and then press X, go to the reference, and then I will have here, did I click the correct one? Yes I did. On this one there, and then takes me to the case set. Here's the function. The command, sorry, and then here I'm on the function graph that I showed you before, and then if I press space, I can choose go to here to the disassembly of it, and then if I press F5, I can go into the compilation of it, and it will also take me into where it was showing me for IDA, and I can also show the same type of view that I had on Ghidra. You see, I have Python here, and I have my two windows, my screens here, program segmentation, yeah, the XView, the structures, the imports, and the exports that I should show you on the tool, and here are the functions. And so here I have the compilation of the code, and here I have it here. But something that IDA doesn't do is that if I click the string copy, it doesn't take me to the string copy. So let's do that on Ghidra. So open Ghidra and then take the vulnerable server. Boom. Okay. So it give me just a result summary with an overview of what I'm gonna import it and what the understanding the binary have, and then you can also change. Oh, something I read on the internet that people like to do is to do this like not inside the code browser, but here you have to go there, edit tool options, and then you can do tools and then use inverted colors if you want to be like a super hackish style. And then you can do this. Oh, no, don't open like that. Oh my God, there. And then it will be all black and white. And then you can open your vulnerable server. And then the first time you open it, it will tell you, do you want to analyze it now? Or yes, we want. But as you can see, I cannot really see the checkbox here. They are really grayed out. So I will select all, and you can change them. If you click there, there are some options that you can tweak out. And I already went through all of them, but you can do it by yourself. Analyze, and then you have to, on the right side of the screen, on the low side, you will see there, and then it's done. And I'm gonna go back to the, save it, and I'm gonna go back to the normal color scheme because this one, it hurts my eyes. Nimbus, like that. Just a second, guys. And I think it was already 14 minutes, guys. Could you please confirm me that I'm not doing this in vain and you can still hear me? Because I think you are really quiet. But we have a lot of people in the room. Let me check the chat before we go forward. Could anyone unmute yourself or open the chat window? Let me see if I can do that as well. Yeah, we are mute. Yep, can hear you. Okay, fair enough. So let's go ahead and continue. But you guys, if you have questions, you can unmute yourself, I think. Let me check that. Yes, everyone is mute upon entry, but you can choose go into your name and unmute yourself. I mean, if you just have a question or something, because I'm not really looking at the chat. So let's continue. Thanks for that. So open here the vulnerable server. I really like the animation that it has. This tool has. So let's go again into KSet. Choose one click on that one, and then and I lost my window, the compiler, no, my disassemble view. I think should be here. That's weird. I know how I lost it. No? Well, that's weird. I know somehow I lost my my disassembly window, but it's not the disassemble view. But this didn't happen before. So let's just close it and open it again. That's weird. I don't know. You know what I'm gonna do? I'm gonna choose remove the binary and choose put it again. Like that. Put it again. Okay, it will just take us a few seconds. Double click. No, the window is still not there. I think somehow I close it. This is gonna be funny to find it again. I don't know that you were able to close it. The compiler. Well, we do have the function graph, but listening memory map. Which one should it be? It should be the find the data. No, it's not that one. It should be the disassembly view or listening well server. Let's check. Yeah, that one. Okay, I don't know how, but I might have clicked here somehow. Okay, it didn't happen before, but anyway, let's move forward. So we go into the case set function, the string, this one here. Just click on it and then go back into the here into the listing, and then we double click into the reference. There you go, and then we will have the decompiled right there. So as you can see, it will take you wherever you click, and for instance, you can see some of them they are not properly named, and we will go into those. For instance, this is doing something, then states value normal, but we can double click into that one, and then we can see that it's actually using send. Yeah, if you click on it, and then it will also take you to the assembly. So it's actually calling send for the socket. So it's we can go back like that, and then we can modify it either here or here. Or you can modify it in the global, you will modify it in the global namespace. So if you modify it here, every time they use this function, then it will be modified. We know it's sent, so because it's sending it to a socket, to the socket that you connect from. So you change it, and you can see what's changed here and here as well. You can also modify variables, and you can. Sorry, how do you modify it? Press the letter L. Just press L, and then it will allow you to modify it. So you can do it here L, or here L, rename function, edit label. You can also add comments into it. With IDA, you add a comment for. Let's do the same in IDA. So boom, let's go to case set. Well, IDA already understood that it was sent, that it was using, and then it's calling function2 here, but also we didn't identify it here. Yes, this is a string and copy. So we can go back. We can check, no, this we are inside stats. So we should be inside, we say case set. Let's go to case set. There. Okay, case set. We can mark it. And then, I don't see it. Gmon case set here. So yeah, identify function2. These two, they haven't been identified. So basically what I'm doing here, guys, is trying to show you what is the difference between IDA here and what we see here on the decompiled of the vulnerable server in Ghidra. So if we, as you can see, these two haven't been, function2 has been identified, but this string and copy and memset hasn't been. So, but you can replace it and add it properly, right? Change the name if needed. Sometimes it's not. For instance, we know if we double click on this one, that is going to be calling as a turn copy. So we press L as to turn copy like that, and it will change it everywhere. And on this case, it was memset, right? Yeah, memset. So we go back and then change it, pressing L. On this time, let's do it here. L, memset. And as you can see, I changed it here, but also change it there. You can also change stack variables, and you can do the same in IDA. But in IDA instead, you have to press N, the letter N instead. So if we want to change buff to buffer, yeah, there you go, change it. And I do prefer the colors of and the easier to read. I mean, I think it's easier to read here in Ghidra than in IDA. In IDA, it looks quite funky with all the blue and the green. And here is more readable, at least for me, even though it has a gray background. But you can change. Of course, you can change it. I mean, sometimes I not mention it because they are pretty obvious, and you can find by yourself, right? Here you go tools, display, and then you can change it. For the decompiler in this case, you can change everything you want. And so we have identified this one. So this is the function 2. If we double click on function 2, then you will find on this case, function 2 is also call at the end string copy. So we can also change this one, string copy. So obviously this is the vulnerable function that we identified, and we're gonna add a comment saying this is the vulnerable function. So on this case, we double click on here, and then we can add a comment in IDA saying this is the one. This is one of the vulnerable functions. There you go. And then we press OK, and boom. And on this case, we press semicolon. And then we have to add a pre-comment. This is one of the vulnerable functions. It has to be a pre-comment. Let me show you why. Because it will show it here, but if you add a post comment, we go there, and it will not be on the decompiler. If you take it out and put it in a plate comment, it will show here. You see, boom, as a plate comment inside this assembly. That's not what we want. Repeatable comment, it will be here, yeah, in this assembly as a great text. So depending on where you want to set the comment into, then you can, on this case, we want it in the decompiler, so we do it like this, and enter. Now we know this is one of the vulnerable functions. This is something that IDA doesn't do by itself. I have to set up the size. So as you can see, the chart destination is giving me the mat from the stack. So you have to click there, and then you have to convert it into an array on the, and set it up for the size that, of course, it detected it. But now I set it up to the size of 72, right? But here's easier. It already showed me the size. I don't know how you can do that automatically in IDA, but I'm sure you can. But I like it for I like it for the easiness of it in Ghidra. So far you can see there are some things that Ghidra does better, some things that IDA does better. But remember, guys, a full license of IDA Pro cost around $20,000. Yeah, so it's 20K dollars, and you have this tool for free. Just imagine the amount of money you can save just by using this tool. Or if you are a student, or you are just starting with your reverse engineering career, and you don't have access into a tool like IDA Pro, and then you have to use of course, there are other tools like Hopper that also pay to use. You have Radari that is open source. Other well, you have of course OliDBG and Immunity and WinDBG. But those are debuggers, right? I think they don't have they have some sort of disassembly, and I think even Radari has some decompiler, or there are some standalone recompilers open source, but not really with this amount of they are not as accurate as what we are seeing here. This is pretty well done. I think it's sometimes it's even better than IDA to read and understand. Yeah. When you are working with some binaries in IDA, sometimes it do some really funky stuff. So you cannot really trust the pseudocode of IDA. And for that purpose, what I like for on Ghidra is that if it does some funky things, I can always click on the function that is I'm using in this case a string copy, just sending this this variable into the buffer, and then I can just click here and see on the assembly code. So it's Lea Lea means load a specific address. That, by the way, you can do a structure info and check for the information of it. But also in IDA you can do like wait, this is showing me. Cannot access the window because the binaries. There you go. So for instance here, we were saying the Lea instruction, I'm not seeing it. That will be, I was clicking here hoping for IDA to identify where is the Lea function. But in any way, for instance, if you don't know about this one, or these calls, or how this move or this sham works, then IDA can also give you. Oh my God, I lost the mouse. So there you go. My bingware is doing some funny things. Oh, there you go. So go in generals, and then auto comments, and then give you some kind of cheat sheet. This is integer subtraction, send. I think this one also has it here. In this case, call string copy, and give you what is using for string copy. This as a comment, right? As well. So call text. What is calling from text? In this case, you can click on this one, and then you will see what it's calling. It's calling the OLS cleanup. We can change it. So what else can I show you guys? Well, the export, the imports. It's funny that they use the same box as I have been using on exploit pack. By the way, guys, if you know who is talking on this presentation, I haven't presented correctly. I'm the owner of this open source project, exploit pack. It's a framework for exploit development. It happens also to be wrote using Java. It's also as well in Java, and we also use the same box. That's a coincidence. So as you can see, we are using the same boxes. I think we both find it on the icon finder. It's a free icon. So in any case, guys, let me show you something else, the scripts. So basically here on the scripts, you have all the scripts. You can write your own scripts as well. You can start with a hello world. You can write your own Python scripts. You can, but I think in the future, what we're gonna see, one of the first things this tool needs is the, of course, memory map, and then yeah, just like I think in NIDA you can do it directly as well. That should be one of the sections like that. There you go. So it's the same. You can see, yeah, there you go. And you can, if you really want to push it, you can also do the same. Put it in the same kind of layout. I think it's like this. No. There you go. I don't know if you can change the name of those, but you should. This is the display decompiler, the CF, and you have like the console, function graphs, assembly functions. That's here, there. Register manager, you can change the register and assume value for a register. Symbol tree is there. Functions, if you load for instance, Microsoft binary that has a PDB, you can choose load the PDB or load it or download it from which folder, and then you can download the PDB from the Microsoft, the public symbols from Microsoft website, or you can use your own PDB file if you have the symbols for, so you can import the symbols. What else you can yeah, parse scissors. Oh, there's something cool about this tool as well, that it also supports the ability to work in an environment with other people, so you can share your progress of your disassembly or reverse engineering progress with a particular binary. If you're working on a malware sample, for instance, that's really cool to do, so you can share with your colleagues. The search function works pretty nice. So for instance, we are here, edit, I search, program text, and then we can search for mem set in all fields. There you go. Or you can choose click here as well, yes, with the middle, and then see if, where is it using it. Yeah, as I showed you in the beginning. So as I say, the help is under contents, and then you have the full API. So as I say, in the future, what I'm seeing from this tool is that one of the first things that we're gonna get is basically a debugger, because that's what it lacks. So it doesn't have a debugger. So if you want to use this tool for more than static analysis, then you have to on a day-to-day basis. I mean, you need a debugger. So you will have to use GDB or even IDA, or go ahead and compare your references. But you can do that because it supports to import the IDA, so you can check your file from IDA, export it, and then you can import it here as well. But yeah, it's quite of a mess. So some stuff like going to here and say, okay, let's go back, and then I want to set up a breakpoint on this function when it's set, then you cannot do that, because there is no breakpoints to set, because there is no debugger to run. So I hope maybe the guys from the NSA will choose out integrated with GDB or something like it, or write their own debugger to be used on this tool, yeah, or as I say, integrated with something else. So you can start working with the disassembly and start with the compilation part of it, and understand the binary and run it and see how it works. Some stuff you have to run it to understand it better. How, I mean, it is easier than doing just static analysis. And to see how the variable evolve, how it goes, you can follow it with the function graph. And then if you're running it, then you can say, okay, we are here, and then I want to go there. Yeah, just follow the flow, right? It's important to to have a debugger. But I think I'm really looking forward to this tool. I will keep using it. Yeah, I think I'm gonna try to invest some time on developing some of the tools that I already made on scripts for IDA. Yeah, and also put it here. Something that I was working on is on kind of a Mona or Peta type of extension, basically finding offsets, patterns in memory, creating rob chains, finding robs, stack pivots, jumps, and yeah, those kind of stuff. Some of them you can do it without debugger, of course, finding the offset of the brown pattern. There is no way, because you cannot run it without the debugger. But some other stuff you can already do it, like finding rob chains and finding jumps, finding maybe bad charts or something like it. And I think I'm gonna start trying to develop those kind of scripts for Ghidra, so I can also help this tool to I'll try to give my 2 cents to this tool. Also, I will try to be part of the GitHub, even though I don't have a lot of time, if the GitHub page keeps evolving. And I encourage you guys to do the same. You just try to invest some time in this tool, because I'm seeing a really bright future for it. And I think so far it works amazing. And I think being an open source tool of this type is kind of a, a really nice gift for us to have. Well, guys, I think I don't want to extend more than an hour. I hope you enjoyed this walk through this amazing tool called Ghidra from the NSA, and I hope you enjoyed as well the training. Sorry for it took more than an hour, but see you on the next one. And if you like the video, you can subscribe to my YouTube channel as well. I'm gonna stop it now, and thanks, guys. Bye.